Okay, trying something new, using my phone to record the videos. So let's do 7.2, simplifying trig expressions. So there are no actual notes that go with this. You will use your identities from 7.1, your reciprocal identities, your quotient identities, and your Pythagorean identities, and manipulate the expression to a more simple expression. Just one trig function is what we're hoping for. Okay, so, and then there may be multiple routes to take in order for this to work, but we should all end up in the same or with the same solution. So let's just start. What I like to do is pull out your identities and look, and let's talk about what I can do with cosecant and what I can do with cotangent and how that might help me. I like to think the route prior to writing it down. So when I think of cosecant and cotangent, I think about the reciprocal identities. And so the reciprocal of cosecant is 1 over sine. And when I think about the reciprocal of cotangent, that is 1 over tangent. All right, so now I've done that. And so I think about tangent. Tangent has a quotient identity that is sine over cosine. And if I do keep, change, flip, that might get me to a more simplified version. So let's try that. Let's go ahead and do keep, change, flip. I'm going to keep that first fraction. I'm going to change division to multiplication. Let me write change right there. And I'm going to flip 1 over tangent to tangent of theta over 1. All right, so I'm going to come back down here and simplify that. That's going to end up being tangent of theta over sine of theta. And so now this is where I'm going to change tangent to sine over cosine. So that is my quotient identity. And again, if I did a keep, change, flip here, that's going to make my signs cancel. So sine over cosine, change to multiplication, and flip to 1 over sine of theta. You can cancel these signs. And let's come back right here. And I'm left with 1 over cosine of theta. And I don't want to leave it as that fraction, especially since I know my reciprocal identities, which is that this is secant of theta. And that's my final answer. All right, let's look at another example. Here we've got tangent squared plus 1, and it's divided by 1 plus cotangent squared. So first off, when I think of these, I think of my Pythagorean identities. And so that numerator would become secant squared x, and my denominator would become cosecant squared x. And so from here, I'm thinking about what I can do to manipulate through this to make it simpler. And so I think about their reciprocals. Now, while the reciprocal identities are not squared, I can still write these as a reciprocal and square that. So let's see where that takes us. So the reciprocal of secant squared x is going to be 1 over cosine squared x. And the reciprocal of cosecant squared x is going to be 1 over sine squared x. And then, of course, I'm going to do my favorite, my keep, change, flip. That's going to be 1 over cosine squared times sine squared over 1. And from there, I'm thinking of my quotient identity. And I'm gonna think of this as sine squared over cosine squared, which we know is tangent squared. And that is where we're gonna stop. Okay. All right, let's do the next example. We've got sine x plus sine x cotangent squared x. So the first thing I see, plus sign, so we've got a binomial, and there's a common term. So I'm gonna take out a GCF. Yay, a little algebra. So sine of x is my GCF. If I factor it out, I'm left with 1 plus cotangent squared x. Now, just this part right here is a Pythagorean identity. So I'm going to change that part. I'm going to leave my sine x, parentheses, 1 plus cotangent squared x is cosecant squared x. And then I know that sine and cosecant are reciprocals of each other. So I'm going to have sine x still there. I'm going to change this to 1 over sine squared x. And if I simplify that, that's sine x over sine squared x. An algebra reminder of what that is like is x over x squared, which is 1 over x. So in this case, we're going to be left with 1 over sine x. And I don't want to leave my answer like that because I know another reciprocal identity that I can use, 1 over sine x, is cosecant x. And that's where we're going to stop. Now, will it always be one trig identity or trig function as a final answer? No. Sometimes it can be a number. Sometimes it can be 1 minus a trig identity. A trig function. So just keep that in mind. It doesn't always have to be just sine or cosine or whatever. All right, so here we've got 1 over sine squared theta minus 1 over tangent squared theta. And so right off the bat, I think about the reciprocal identities for both of these. Even though this is a subtraction problem, I'm still thinking of the reciprocal here. 1 over sine squared is cosecant squared minus 1 over tangent squared theta is cotangent squared theta. And then that itself is a Pythagorean identity that if I manipulate it just a little bit, I can get an answer. Cosecant squared theta minus cotangent squared theta is 1. And that's my final answer, 1. So that one was short. One last problem. We've got, scoot over this way, sine x minus cosine x squared plus sine x cosine x. So, starting off, I'm focusing right here on this binomial squared, because remember a binomial squared means to write it twice and multiply, or to full, double distribute, whatever terminology you learned in Algebra 1. We just have trig functions in them. So that's where I want to start. Let's do that. So just this part right here, I'm going to write out 2 times and multiply, and then I'll come back and bring down that second part of the binomial. My red pen's going out, so I'm going to switch to pink. All right, so sine x times sine x is sine squared x. Sine x times, oh, that should have a minus there. All right, so sine x times negative cosine x is negative sine x cosine x. Negative cosine x times sine x is also negative sine x cosine x. Negative cosine x times negative cosine x is positive cosine squared x. And I have like terms right here, so I'm going to go ahead and combine those. Sine squared x minus 2 sine x cosine x plus cosine squared x. And then I've got to bring this down. Plus sine x cosine x, which is a like term with our negative 2 sine x cosine x. So that'll simplify again. Sine squared x minus 1 sine x cosine x plus cosine squared x. And so from here, I want to stop and think, is there something else that I can do with algebra? Like, can I man factor this? That would be a positive 1 and a negative 1. So let me just work. Two things that multiply to make positive 1, but add to make negative 1. No, so I can't man factor. All right, so then let's just try to manipulate this using an identity. So what I want to do is write my squared terms together. Sine squared x plus cosine squared x minus sine x cosine x. This is a Pythagorean, which would be equal to 1, and then bring down the rest of that. And just based on the identities that we currently have, I can't do anything else. This is going to be my final answer. 1 minus 1 sine x cosine x. And that's it for 7.2. If you have any questions, comment below.